Well, hello computer geeks, electronics nerds, retro computing enthusiasts. Welcome back to my channel and welcome to episode 10 of me trying to resurrect this old Teletek Systemaster S-100 based single board Z80 computer. And since episode 9, I can report there has been some significant progress in getting this thing up and running. Unfortunately, that progress did not include getting the floppy drive emulator working. I spent a lot of time on that the other day, and still no joy. And I'm not ruling out anything at this point. I mean, it could be either a hardware or software configuration that I'm doing wrong. It could be bit rot in the original bootloader EEPROM that came with this thing. It could be that the disk images I have that I'm trying to boot off of this thing really aren't the right disk images. So there's all kinds of possibilities, and I haven't been able to rule out any of them yet as the culprit or one of the culprits of why I can't get this thing to boot up. But there has been progress in another area. Back in episode 9, I was starting to write my own firmware. And I have actually made a lot of progress in that area. I have got my own monitor program that I have written myself in this EEPROM here. It fits in 2K and there's still a little space left over. I am amazed at how much I got in there. And it allows me to do all kinds of stuff. And writing the monitor was a lot of fun. At the end of episode 9, I had get care and put care routines written. And they are kind of the basis or the foundation upon which everything else is built. It's like Lego bricks, you know. You get a couple of Lego bricks built, and you can use them to build bigger structures, and then you can use those bigger structures to build yet bigger structures. And it's a lot of fun writing this firmware in Z80 assembly language, which I've never really done a lot of work in assembly language before. And I'm surprised at how quickly I've picked it up and how well it's been going. Now, I have borrowed kind of heavily from other people's monitors, not so much verbatim, but for looking at how they've done things, because I can't just cut their code verbatim out and put it in here because the hardware is different and, you know, the routines I've already written that they're going to depend on are different, so there's got to be a lot of rework to do it. Mostly I look to see how they did things, and then I try my best to do it my way in there, and when I can. A couple of times I have cut things out of other people's code and then just modified it to make it work, just because some of those routines were really complex. But, you know, and I'm still kind of a learner. But I got it working. I'm amazed. I got it working. So there are a lot of functions in here that allow me to exercise this thing and do all kinds of stuff. So let me reposition the camera so you can see the computer monitor over here. And we'll fire this up. I'll show you my monitor program in action. Okay, now I've got the camera zoomed in on my junky old laptop I use for just interfacing the computer out here. Not the nice new laptop I use for writing code on. That's different. Alright, so let me fire up the Systemaster. Look at that. Look at that. That's impressive, I do say so myself. So we are running Z80 Mon version 0.240. The name Z80 Mon is important because I'll talk about that in a minute. Version 0.240 because there's a lot of work that needs to be done on this monitor yet. It is still rough around the edges. And I need to make some changes to it, and we'll talk more about the changes in a little bit. But look at the commands we've got here. Mem copy, we can copy n number of bytes from origin to destination in memory. We can do a memory dump. We can dump a 256 byte block of memory to the console. We can edit memory from starting address until X is pressed. We can memory execute. We can jump to an address in memory and start execution from there. I'll demonstrate some of these too here in a little bit. We can print this menu of commands. That's help. So if I put help, it just reprints all that again. Let's see. load an Intel hex file into memory, that's going to be very, very, very convenient. Let me tell you. Receive a binary file and place it in memory. Read a byte from an I/O port. Send a binary data from memory to the console. Write a byte to the I/O port. And all this stuff works. It's taken a lot of debugging. It's been, oh, how long has it been since episode 9? I've been working hard on this since then. I'll show you the dump routine right now, the memory dump. And we'll just dump part of the ROM out. So there's the first 256 bytes of the ROM right there dumped out. And I am very proud of the memory dump routine because this is almost all my own code. I looked at how other people were doing it. I saw what they were doing. I figured out how to do it myself, and I figured out how to improve on it. I really like the fact that I've got the addresses of the individual bytes up across the top, as well as down the side here. So that makes it pretty easy to see that, okay, 04 over here is at 0000A. Yeah. So, or works for me anyway. I like that. And let's see, we've got some other stuff we can do. Let's see, if I hit yes for more, it'll print the next 256 bytes, and it'll keep that up until I go no. So that's pretty cool. Memory edit. We put in an address. I'll put an address in high memory somewhere. Let's say 5,000. And that's what there. And I can just start entering, you know. I have the ET3400 microprocessor trainer from Heathkit. And this is how you enter the programs into it with a memory edit feature like this. And I wanted to emulate that in mine because it's so easy to just, type in stuff like that. So I put in the X, it'll end. But now if I was to dump the memory up there at 5,000, look at that. There's my edits. 0, 1, 2, 3, 4, 5, 6, 7. It works. Cool. So I can type in a program this way and then jump to it with the go command and run it. Or there's another thing I can do. Let's see if I do more. No, I don't want more. Command I loads an Intel hex file. So it's just sitting there waiting for the file to be loaded. So if I come up here to the top, which you can't see, and file, send file, and I will send this file right here. So, okay. There we go. That file was sent out to the Systemaster. It's now residing in memory at 4,000 hex. So if I go to G 4,000 hex and hit enter, that program is now running. And what does that program do, you ask? Well, it's a little counter program that's outputting to the parallel port here where I have LEDs hooked up. Now this program, this Intel hex loader program, is going to come in very, very handy to me because I have complained bitterly in the last few videos about the fact that I am limited to 2K here unless I really get surgical on this board and start cutting traces and putting on bodge wires. I'm limited to 2K. Now there are a few other ways around that. I mean, I could get myself a whole S-100 rack and put other cards in it, including one with more EEPROM chips, and go that way. That's an expensive option, let me tell you. It also takes a lot of space. I've also thought about building a daughter board that would fit underneath the EEPROM, and maybe putting a few special sockets underneath some of these other chips where I could steal signals from those under those other chips and running the wires to the daughter board, and then I can do my own memory decoding on this for the EEPROM and put whatever size EEPROM in there I want. That's a possibility for the future too. May do it that way. I may get out the X-Acto knife and the soldering iron and just cut the traces and put the baud wires in and just be done with it. That's a possibility too. But now I've got a program where I can load an Intel hex file into memory and I can execute it. So I'm not really limited to 2K anymore, as long as I have the ability in this 2K to get files into memory and then execute them. So I can load, a big file into memory somewhere and run it. So I'm not really, that limited anymore. So that's a beautiful thing. Now, I was also talking about how the name of the monitor, the Z80 Mon, has some sort of meaning. Well, I've been working on another project. I gave you a look at it a video or two ago with my breadboard Z80 computer over here. Yeah. So you guys have seen this before. I was writing software on this to test aspects of this because I knew this worked. So I was writing stuff here, made sure it worked here, then plugged it in here, and made sure it worked over here. So now it's going the other way. I've been writing, this monitor over here, and this monitor is going to come in really handy to turn this into a real full-fledged computer. And it's going to be named the Z80. Basically, the acronym means just another Z80 computer, because there's so many of them out there. It's going to be built on a breadboard to start with, but I'm going to take it further than that down the road. I have big plans for this. So, we started out writing software on this for the Systemaster. Now we're writing software on the Systemaster for this. So, it's a beautiful thing. So anyway, let's get back to this. Make sure we're in sharp focus. So that's the Z80 monitor. Like I said, it needs a lot of work. One of the things I need to do to it is I need to rewrite the get care and put care routines and put them in certain places in low memory so that basically, like, the Z80 has all these reset positions in memory, in low memory. RST00 is going to be like, start over again, like you're pushing the reset button, but there's RST, 08 and 16 and so on and so forth. So a lot of monitors have the low-level routines in places like that. So if I use the Intel hex file loader program down here to load stuff into the machine outside of the monitor space and run it, it can still make calls to the monitor to do things like write to the screen here, write to the console, read from the console, and use a lot of the other monitor functions. So I need to rewrite it to do that. So, that's why our version number is pretty low right now. Let me reset this. There's no way to get it back out of that counter program without just doing a reset on the machine. Let's clear the screen. And we'll do an H, and there we go. We're back. Okay. So I need to, like I said, I need to rewrite that, make it a little more user-friendly for other software. And over here is sort of a list of the available commands and subroutines that these commands are built on. I got memcopy, memdump, memedit, memexecute, help, hex load, bload, import, bdump, and outport. And here's all the stuff underneath the little miscellaneous subroutines that I've written to accomplish all this stuff. So yeah, there's quite a few of them. And I've amazed myself. It all actually works. It's amazing. Like, for instance, let's go back over here. Let's take a look at this. As part of the boot up process, as it reaches different points in booting up the system, it'll output different numbers. So it'll output numbers to the parallel port during the boot up process as it reaches certain milestones. It'll output 1 when it reaches a certain point, it'll output 2 when it reaches another point, it'll output 3 when it reaches fully booted up. So we're at 3 right now, so we're fully booted up. You know, it's just troubleshooting code I have included in the monitor. Well, if I come over here again, and I hope I'm not making you dizzy by going back and forth like this, but if I come over here and I do a write to the port, W, port number, now that PIO there is on port 4, so 04, value, let's go FF. Okay, now let's look at that output port again. Look at that, they're all on. It works. And of course, if I was to read back from that port now, R, port number 04, FF, look at that. So yeah, I'm pretty stoked that this is working, and I think once I get you know, some modifications to the monitor made, I can push stuff into, you know, memory above the monitor ROM somewhere and then jump to it. I would like to get, you know, BASIC on here would be nice. There's a couple of different versions of BASIC. Again, I'll have to get either my monitor to work with the BASIC, so it's got the input-output functions available to it, or I will have to modify somebody else's monitor to work with this within 2K in order to make the BASIC work. I can also do some other stuff that I'm seriously considering. Like, I would still like to do some more troubleshooting on the virtual floppy, and maybe even hook a real floppy drive up to it. So what I could do is I could write some routines and put them in higher memory above the monitor and just probe around and see if I can, you know, get data in and out through the floppy drive port, just to see if everything's working. I don't know if everything's working. You know, like I said, everything's still on the table. I haven't ruled out that, you know, hey, maybe the floppy controller chip is bad. Maybe some of the interface chips are bad. I mean, so far everything's worked on this board that I've got working, but, you know, there's just too many possible culprits for why the floppy drive isn't working, and I'd like to start eliminating some of them. And I could do that by, if I could just talk to the floppy controller there and look at the data coming into it, maybe send some data out of it and monitor all that and see what's going on. So I can maybe at least eliminate the hardware up there as a problem. So that's a possibility. Basically, having this monitor program has opened up a whole world of possibilities for me with getting this up and running in the future. So, as well as getting this up and running in the future. So, I am really enjoying writing this Z80 assembly code and just having a blast with it. And I think it's going to come in very handy several different ways down the road. I said I would make this code available to anyone who is interested. So if I get enough positive feedback that there's people who want, you know, to see this code, I'll put it up somewhere. I don't have a GitHub account, but I do have my own blog. I can put it on there for now. You know, maybe I'll get a GitHub account down the road, possibly. But I assume that this hardware is just a little too specialized to really be of interest to too many people. I mean, there aren't a lot of these Systemaster boards out in the wild. You know, they're pretty rare. I should have picked a project that was a little more common, but you know, hey, if it's easy, anybody can do it, right? But yeah, but if there is sufficient interest in wanting to see the software I've written, I will make it available. Just, you know, leave me a comment in the videos, send me an email, whatever. And I'll eventually put it up somewhere probably anyway, even if there's not a whole lot of interest. But if there is a lot of interest, it'll spur me to get it done quicker. Okay, well, thanks a lot for watching. I hope you found this video at least a little bit interesting and informative, or at least killed a little time in an enjoyable manner. Give the video a thumbs up, give it a like, and subscribe to see future videos. There will be more videos probably on this, videos on this, maybe videos on software development, and lots of other stuff down the road. And subscribe to see those future videos, and press the little bell icon that YouTube makes you press to see those videos when they come out. And thanks again for watching. I'll see you in the next video.